This is electromagnetic induction. Build up your understanding 41st question from the book Pathfinder. So question is, there's a lamp which is tube light. It has a choke coil which is an inductor, and in normal mode choke coil is in series with the tube. Tube behaves as a resistance, and the starter is an open switch, right? So till now, what is the idea? The idea is they're talking about one LR circuit, and then in a particular lamp, the voltage drop in the coil is eta times that of the tube. Remember, tube was resistance, and this is the choke coil was inductor. So in voltage drop in inductor is some factor of voltage in tube. Now, if it is, so that is what we were discussing. This is an ideal inductor of inductance cell. Now, how much capacitance we connect in parallel with the lamp so that power factor becomes unity omega is given. So let us see how do we solve this. So initially, when there is no capacitor, this is given. Voltage drop across L is LR circuit. This is choke coil. This is tube. So VL is equal to, this is RMS value, IRMS into omega L, and voltage drop across R is I into R. Right? This we know. It is given that VL is equal to voltage drop across the choke coil inductor is eta times voltage drop across the resistor. So that is what I have done here. IRMS cancels and you get omega L is equal to eta omega R. Fine. Now, after that, we have to find out how much capacitance we should connect such that power factor becomes unity. So first of all, let us see what is power factor and what is the meaning of unity power factor. So power factor is this. Suppose there's a circuit, Z is the net impedance and R is the resistance. Then cos phi is called power factor, which is equal to R by Z. Unity power factor means it is a purely resistive circuit. So unity power factor means cos phi is equal to 1, which implies phi equal to 0. Phi 0 in this diagram, that means Z is equal to R, right? So purely resistive circuit. So that is what now we will do. This condition we will apply. How do we find impedance of the circuit? I will use complex number method to find out the impedance of this circuit. So in complex number, impedance of L is how much? Reactance of L inductor is j omega L. This is R only, and this is 1 upon j omega C. So this combination is in series, right? After that, with this combination, capacitor is in parallel. So that is what I'm going to do here. So R plus j omega L, let us see the diagram also. So this is in series, R plus R1 plus R2. So once you write, this is what we know, that once you write these reactants in complex number form, then you can treat them as normal current electricity circuit. So this is a resistance. You can treat this as a resistance of j omega L. You can treat this as a resistance of 1 upon j omega C, right? So that is the advantage of complex number method or phasor method. So here this is in series, so R plus j omega L. And then now I've used R1, R2, R1 plus R2. This is what happens in current electricity. If you have this, suppose, imagine there's a resistance here, another resistance here. So R1 plus R2 and this. So with this combination, this is in parallel. So this combination, how much it has? R plus j omega L, right? So it is like this combination and this combination are in parallel. So R1, R2, R1 plus R2. I hope you understand. For power factor unity, coefficient of J should become 0, right? Then only because when you get in this diagram, when you get Z as R plus J something, right? So this is R, that's something, that coefficient comes here. So if this is 0, that means the coefficient of J should be 0 in the power factor. Sorry, in the impedance, not in power factor. So that is what now we have to do. After that is just the calculation. So you can multiply by the conjugate of this in numerator and denominator. So that is what I have done here. And after that, coefficient of J you can equate to 0. So if you do that, you will get this. Some calculation steps I have skipped. You can just verify this. And after that, since R is not given, answer is in terms of L and omega. So we will use first equation where we have found eta R is equal to omega. So R we will eliminate from this and we get this as the answer. Fine. So that's it. It's a very, very good question from AC circuit. If you see in JEE Advanced AC circuits, questions will be more or less like this one. Simple questions. So it's a very, very important question for JEE Advanced. And if you have liked this video, like my analysis, please hit a like to this video and please subscribe to this channel also. Thank you very much. All the best.